Okay, good morning. So today we are going to solve the problems of 8.1. Okay, today will be a problem solving session, right? Where we will be using the concept that we have studied in last class and last class. Morning, Aryan. Okay. Okay, so it's already 11:35. So we'll start now. Okay, because people should join before 11:30. So they are making the habit. So I won't wait anymore. Okay. Okay. So let's recall that what we have studied in last class. Okay, before starting, let's recall what we have studied in last class, right? So basically we were focused about the concept of acid base conjugate, acid conjugate base. Okay, then behavior of acid and base in aqueous solution we have already covered. Okay, so this we have covered till last class, right? Now in last class we basically saw the relationship between alpha, Ka and C, right? Application of Oswald dilution law, right? And then we saw this expression in concept test, right? Now how many of you remember this? Just raise your hand. How many of you remember this? K into Kb is equal to Kw, or K1 into K2 is equal to Kw for conjugate acid base pair, right? We discussed this in concept test, yes, right? We gave the example of NH2 minus and NH3 or NH4 plus and NH3. Okay, so for conjugate acid base pair, Kw is equal to Ka into Kb. This is only possible for conjugate acid base pair. For conjugate acid base pair. Okay, right? So this is what we have to keep in our mind. Okay, then which of the strongest constant base in the following anion? So we know that stability of an ion is more, right? Then basic strength will be weak. Basic strength weak, right? Because if stability is more, it means it is stable. It don't want to give electrons, right? Everyone, tell me, right? Okay. Now it depends on oxidation number. If you remember from periodic properties and chemical bonding, it depends on the oxidation number. For example, ClO minus, the oxidation number of Cl over here is +1. ClO2 minus, the oxidation number is +3. ClO3 minus +5, and ClO4 minus +7. So we know that oxidation number more, right, means it is has more tendency to accept electrons, right? It is more stable, okay, right? As so HClO4 will be strongest. It will be strongest acid. It will be strongest acid, right? Tell me. We have studied now. HClO4 will be strongest acid, right? Strongest acid. Okay. So the weakest acid will be this. Now, if it is the weakest acid, so obviously its conjugate base would be strongest. Yes or no? Tell me, yes or no? Right? Okay. Okay, everyone. Now, see. Right? So basically this is the dissociation equation, right? This is your acid. Okay, it will give H plus. This is a base which will accept H plus. Okay. Right. Then Lewis theory, we studied that any acid or base, okay, can be classified into on three bases, right? The first basis is presence of H plus and OH minus, which is Arrhenius theory. Second is presence of H plus. Only H plus means if any compound is giving H plus, then it is your acid. If it is accepting H plus, then it is your base, right? Now the third theory is Lewis theory, which is based on lone pair electrons. So I said that electron rich, right, which can give electron are bases, and electron poor, right, or electron deficient are acids, right everyone? So I hope all of you remember this. Okay, right? So this is what we have studied. Now apart from that, we studied the dissociation. Okay, dissociation. Now what is the dissociation? Dissociation of weak acid, right, and weak base. That's what we have studied, right everyone? Okay, so we will focus on, we will focus on problem solving, okay, based on those concepts. So let's see some problems. Now in pre-reading, I guess everyone can do pre-reading, right everyone? Everyone can do pre-reading. Compounds that conduct electricity in the aqueous state are called, message me everyone. Yes, electrolytes, very good. According to Arrhenius theory, bases are the substance that produces, yes, okay, very good, OH minus. For dash, the conjugate base is OH minus. For dash, the conjugate base is OH minus. Yes, H2O. Fourth, according to Lewis concepts, acids are species that, yes, accepts, very good. Then fifth one, molarity of pure water is dash. Molarity of pure water is, see, it is molarity, right, which is concentration. Okay, concentration. So it is 10 to the power minus 7, right? Yes or no? Because when you talk about molarity of pure water, right, so H2O will break into H plus plus OH minus. So concentration of H plus and OH minus is 10 to the minus 7 now. So it should be 10 to the minus 7, right? Okay, next, expression for pH, all of us we know, that is minus log concentration of H plus. Okay, okay. Now in class exercise, now question number 1, 2, 3, right? Yes, very good. Question 1, 2, 3. Let's see question number 1. Okay, we will discuss each and every question. Okay, then we'll try to solve some additional problems also. So we have, write the balance equation for the dissociation of each of the following Bronsted-Lowry acid. So I hope everyone can solve the question number 1. CH3COOH will give what? H plus plus CH3COO minus, right? H2SO4 will give OH plus plus SO4 2 minus, right? But this happens in 2 steps. Okay. Now HSO4 minus, so basically it will happen in 2 steps. The second step, it's like this: H plus, first will be H plus, and HSO4 minus, simple minus, H plus plus, HSO4 minus. Okay. Now this HSO4 minus will further dissociate to give H plus plus, SO4 2 minus. Right, everyone? Got it? Tell me, got it? Yeah, it will be 55.55. Okay. Sorry, my bad. It will be 5.55 only because, see, when you talk about molarity, it's number of moles, right? So when you talk about molarity, it is number of moles in 1 liter of solution. Okay, so in 1 liter, we will have 1,000 grams. 1,000 grams means 1,000 by 18, which is 55.55 moles. So it will be 55.55 by 1. Okay, right? Okay, so question number 2. How much should 10 power, how much should H plus concentration of solution be changed to raise the pH by unity? Tell me. It is very easy, right? You have to change pH by 1, pH by 1, right? So concentration of H plus should be changed by how much? 10, yes or no, right? 10 times, yes or no, right? Because it is log 10 base 10. Got it? Right? So yes, either you increase by 10 times or decrease by 10 times, because it doesn't say na it should increase or decrease, right? So it's just 10 times. Okay, right? Okay, now question number 3rd. Let's see question number 3rd. Now tell me, all of you just tell me, out of these, right, identify Lewis acid and Lewis base. Okay, first one. Okay, raise is given na, then to reduce, right? Then reduce. Now, first one, tell me which is acid, which is base. Tell me everyone, out of this, which is your acid, which is your base. Yes, very good. Since BF3 is your electron deficient, it is your acid, and NH3 have lone pair, it is your base. Okay, very good. Second one, everyone tell me second one. Yes, very good. Ca2 plus, since it is electron deficient, acid, CO3 2 minus, it is electron rich, base. Very good. BOH को whole thrice. Yes, very good. It is your acid and this is your base. AlCl3, this acid, this base. Negative charge, right? Mostly base. See, Sneha, BF3B, right? B have only how many electrons? Tell me. 6 electrons, right? So B, when you talk about B is your electron deficient compound, yes or no, right? So if it is electron deficient, okay, then obviously it will be acid. Okay, everyone, got it? Okay, now last one also SO2, right? Again in SO2, right, it is your acid and OH minus is your base. Okay, I hope everyone got this. It was easy. Now let's see question number 4. Okay, let's see question number 4. Right, everyone, I hope that you have tried. Okay, now pH of NaOH, first of all, NaOH is strong electrolyte or weak electrolyte? Tell me step by step. It is a strong electrolyte or weak electrolyte? Strong electrolyte. Very good. So should we use the concept of equilibrium? Tell me, should we use alpha and all those things? No, right? That's the first question you should ask, right? No. Okay, so we just have to use this only. pH is equal to minus log concentration of H plus. As simple as that. As simple as that. We have to use just this one. Now, pH of the solution is 10, right? So this is equal to 10. Okay, right? This is equal to 10. Now tell me, if this is equal to 10, what is concentration of H plus? Tell me, what is concentration of H plus? It is 10 to the power minus 10 now, right? 10 to the power minus 10. This is the basic definition of log. Log a base b is equal to c, then a is equal to b to the power c. And since we have negative, so negative will go this side. Okay, right? Right, everyone? Anyone have any issues? Right? Now, we know that this is concentration of what? H plus. So what is concentration of OH minus? I hope all of you remember, right? Concentration of OH minus is 10 to the power minus 14 by concentration of H plus. Yes or no? Yes or no? Right? So this is equal to what? 10 to the power minus 4. Concentration of OH minus is 10 to the power minus 4. Right? Now, we know that NaOH, 1 mole of NaOH will produce 1 mole of OH minus. Yes or no? Right? So 10 to the power minus 4 molar and OH minus will be produced by 10 to the power minus 4 molar NaOH. So the answer is 10 to the power minus 4 molar. Okay? Got it, everyone? Tell me. Everyone got this? Tell me, everyone. Okay, very good, everyone. Right? Very good. Now, can you try second one? Try second one. I'll give you 2 minutes. Try second one. Okay, very good. Right? Very good. Yes. Sneha. Yes, very good. So we will do the same thing. Again, pH is 12. So concentration of H plus is 10 to the power minus 12. Easy. So concentration of OH minus is 10 to the power minus 2, right? Okay. Now we know that CaOH whole twice will dissociate like this. Ca2 plus 2OH minus, right? Means 1 mole of COH give 2 mole of OH minus, right? So 1 mole of OH minus will give half mole of COH ka whole twice. So concentration of CaOH whole twice is half of concentration of OH minus. Got it, everyone? Right? So this is half into 10 to the power minus 2, which is 5 into 10 to the power minus 3 molar. That is your answer. Right, everyone? Got it? Easy? See, for strong acid, strong base, it is easy. Okay? Right? You don't have to use any equilibrium concept. Now, question number 5. Everyone, just think about question number 5. Just think about question number 5 for 2 minutes. We'll discuss. I hope all of you have solved. Okay, let's see, right? Let's see this problem. Now, a 1.2 gram sample of Mg reacts with 50 milliliter of HCl solution whose pH is this. Now, first of all, right? pH minus log concentration of H plus, right? This is equal to minus 0.602. So, log concentration of H plus is equal to 0.602. Now this is, see, it is given, this is equal to 4, right? This is equal to log 4. Got it? Yes or no? Because this is 2 into log 2. right? So 2 into log 2 is log 4. So concentration of H plus is given as 4, as simple as that. Okay, right? Concentration of H plus is given as 4. It is given that concentration of H plus is 4. So concentration of HCl is 4. 4 given, right? Anyone have any issue? Tell me, anyone have any issue? This is the concept. Okay, apart from that, it is the question of mole concept. Now just think about this. Mg plus HCl gives MgCl2, right, plus H2. Now, what is the pH of the solution after all Mg has reacted? So we know that Mg, molecular weight of Mg is 24, right? So it is how many number of moles? 1.2 by 24 number of moles. Okay, right? 1.4 by 24. HCl is 4 molar, right? 4 molar. Okay, so number of moles is, tell me, 4 into 100, right everyone? Sorry, 4 into 50. Okay, so 4 into 50 into 50. It is millimoles. Okay, it is millimoles. So divided by 1000. Sorry, it's 4, not 40. My bad. Okay, got it? Tell me, got it? Right? So you have to see out of these two. Obviously, it will be 2. Okay, because balancing the reaction will be 2, right? So this is a balanced reaction. So it will be 1.2 divided by 2.5. It is how much? 0.05. Yes or no? Yes or no? And how much this is? It is 1 by 5. 1 by 5, which is 0.2. Okay, right? So which of these two is a limiting reagent? So this is divided by 1, this is divided by 2. Okay, so obviously this is a limiting reagent. Okay, now if this is completely used, right, so we know that after it will be used, right, it will be left 0.1 molar. HCl will be left 0.1 mole, 0.1 mole. Yes or no? 0.1 mole. Yes or no? Because 1 mole of Mg will require 2 mole of HCl. So 0.05 mole of Mg will require 0.1 mole of HCl. So after this, we will get what? After the reaction is completed, right? We will get 0.1 mole of HCl left. Yes or no? Tell me. Yes or no? Tell me, everyone. Okay, everyone is getting this because it will be 0.05 minus 0.05, right? Because it will consume, okay, it is a irreversible reaction, so it will be used up. Okay, it will be 0.2 minus 0.1 because again 2 into 0.05, so you will get 0.1 and 0.1. So concentration of H plus after the reaction is over, okay, is 0.1 into divide by now what is total volume? This is number of moles of H plus. What is total volume? Total volume would be, tell me, 50. So divide by 50. Got it? Right? 50. This is your H plus concentration. Then can you find pH? Tell me, everyone, can you find pH? Did you get this problem? Yes or no? Tell me. Did you get this problem? Right? Take your time, everyone. Take 2-3 minutes. Okay, take your time and try to understand what is happening over here. This is strong. Yeah, it is 50 milliliter, na? Yes. So into 1000. Yeah, because it is 50 milliliter. Yes. Yes, because yes, very good. Because it will be 2, right? If it is 2, then pH is minus 0.301. As simple as that. Got it? This is your answer. Okay. Okay, everyone. Anyone have any issues? Tell me. Anyone have any issues in this? Got it? I hope the concept is clear. Everyone? Okay, very good. Now next, question number 6, right? Let's see question number 6. What is the pH of the solution obtained by dissolving 600 ml of HCl, right, at 27 degrees centigrade and 0.8 atm and 2 liter water solution? It is easy, right? Try to find it. Try to find it. You just have to use PV is equal to nRT. Yes or no? Right? Yes. Find N. Right? Using N is equal to PV by RT. Right? You can find N. Then concentration of H plus is N by V. Right? Then pH is minus log concentration of H plus. Okay? Right? Try to do that, everyone. Try to do that. Step by step, try to do that. Okay, everyone, let's see. Right? So I hope all of you got the answer. Tell me. Yes? I hope all of you could solve this. Right? So first, let's see N. N is equal to P. P is 0.821 into V, which is 2. Okay? Because it is given as 2 liter water solution. Okay? So okay, in first case, see, in first case, you have to take volume as 600 by 1000. Okay, in first case, in order to calculate N, because this is the volume of your acid now, right? So in first case, you have to take 600 milliliter, right? Okay, into R 0.0821. Okay, into temperature it is 300, right, everyone? So this is easy to calculate. 2, then this is 10 times. Okay, right? So it is N is equal to 0.02. Anyone have any issue? Then we know that concentration of H plus is equal to N by V. Now this case is 2 liter because it is your total volume of the solution. So it is 0.02 by 2, which is 0.01, which is 10 to the power minus 2. Got it? So if concentration of H plus is 10 to the power minus 2, what is pH? pH is 2, right? Got it, everyone? Tell me, got it? Okay? Okay, everyone. Now question number 7. Let's see question number 7. Okay, very good, everyone. If it's clear, very good. Now question number 7. Now calculate the change in pH if 100 milliliter of solution of with pH 2 is mixed with 100 milliliter of solution of this. So first, what you have to find? Calculate initial number of moles of H plus, right? Tell me. Calculate initial number of moles of H plus. right? Then number of moles of H plus added, okay, right? Step by step, okay? First, calculate initial number of H plus, moles of H plus, then moles of H plus added, then, okay, final concentration of H plus, final concentration of H plus is equal to N total by V total, okay? Now let's see how to do that. pH is 2. So initial concentration of H plus is equal to 10 to the power minus 2. Now volume is 100 milliliter, right? 100 milliliter. So number of moles of N1, which was there initially, is concentration to volume M1V1, right? So which is 10 to the power minus 2 into 100 millimoles. See, it is millimoles. It is 1 millimole. Okay. Now, what amount of H plus is added, okay? So N2, which is amount of moles of H plus added, is again M1V1. So 100 into 0.3, 0.03. So it is 3 millimoles. So N total is equal to 4 millimoles, okay? Right? And V total is equal to how much? 100 plus 100, 200 milliliter. So concentration of H plus final is equal to 4 by 200 because millimoles milliliter will cancel each other, right? So it is, tell me how much? 1 by 50, right? Got it? Okay, right? So 1 by 50 can be written as, sorry, 1 by 50 can be written as 2 into 10 to the power minus, just multiply by 2 now, 2, right? Got it, everyone? So this is your H plus, okay? Afterwards, initial pH is 2, final pH is this. pH is equal to, tell me, this is concentration of H plus minus log concentration of H plus, right? So what is the difference? Difference is of this log 2 now. Delta pH will be log 2. Agree, everyone? Tell me, agree? Yes or no? Actually, it is minus log 2, okay? Because it is final minus initial now. Tell me, anyone have any issues? Anyone have any issues? Think about it and let me know. Okay, very good, very good. So can you solve question number 2? 7th second, right? It's same like that. Try to solve 7th second, okay? Okay, let's see, right? Yes, I got one answer. Okay, now let's see, right? The question is, if 100 milliliter of 0.1 molar KOH is added in the above solution. So in above solution, what was the concentration of H plus? Tell me, what was the concentration of H plus, final H plus? It was 2 into 10 to the power minus 2. Yes or no? Yes or no, right? Now, how much moles of KOH is added? It is, tell me, right? So number of moles, so this is concentration. Number of moles of H plus will be 2 into 10 power minus 2 into 200 because the volume was 200. Okay, so it was what? 4. Yes, 4. Okay, okay, everyone. Now, how much this is? This is 1 mole. 1 mole, right? So 1 mole of OH will neutralize 1 mole of H plus, right? So number of H plus, number of moles of H plus remaining, is equal to 4 minus 1, which is 3 moles, right? And what's the total volume? V total will be again 100 plus 100, 200 plus 100, 300, 300. Okay, got it? Yes or no? Yes or no? So this is millimoles, by the way. This is millimoles. This is milliliter. So again, H plus concentration will be what? 3 by 300. Okay, which is 10 power minus 2. Right, everyone? Right? Okay, so it will still be acidic. It will still be acidic. Got it? Tell me, got it? Anyone have any issue in this? Tell me, everyone. Okay, very good, everyone. Right? So question number 7 we have discussed. Now, 8-1, 8-1, 8-1. We will discuss these two questions also. Okay, we will discuss 8-1, 9-1 also. To see this, calculate H3O plus, which is H plus only. Cl minus, OH minus in 100 milliliter solution of HCl. It is easy. Tell me, easy? Yes or no? First one is easy. Concentration of H plus will be same as concentration of H plus will be same as concentration of Cl minus. It will be same as concentration of HCl. Yes or no? Yes or no? Right? Very good. Okay. Now concentration of OH minus will be 10 to the power minus 14 by concentration of H plus. Okay. So 8-1 is very easy, super easy 8-1. Right, everyone? Okay, very good. Second one, 8-second. 8-second is same as 7th one. Don't you think that 8-second is same as 7th one? Right? So I hope all of you can solve. If you have understood question number 7, you can solve question number 8. Okay, now let's see 9th one. At 90 degrees centigrade, concentration of H3O plus is this, right? Okay, now calculate the self-ionization constant of water at 90 degrees centigrade. Okay, right? Second, what's the pH of water at this temperature, right? So I'll give you 1 minute, try to solve question number 9. Yes, so see, self-ionization constant is your Kw. So Kw will be 10 to the minus 13 because it will be concentration of H plus into concentration of OH minus. And for pure solution, the concentration of both H plus and OH minus are same. Okay, right, everyone? Yes, very good. Now, pH, right? It will be 6.5, right? Now, 3 different solutions. Assign their nature. 6.5, it will be neutral or acidic or basic. 6.5 is just neutral, na? 6.5 is neutral. 6.2 acidic, 6.5 basic. Okay, got it, right? Now predict whether the dissociation of water is exothermic or endothermic. Now think about this. Temperature is increasing. K is also increasing. Means reaction is going forward, right? Then tell me, exothermic or endothermic? Right? Because at 27 degrees centigrade, K was 10 to the minus 14. Now it is 10 to the minus 13, which is more than 10 to the minus 13. Sorry, 10 to the minus 14. So what do you think? It is endothermic or exothermic? Yes, very good, endothermic, right? Because if temperature is increasing, right, and reaction is shifting in forward direction, so obviously it is endothermic. Endothermic. Okay, right, everyone? Tell me, right? So 8.1 we have discussed. Yes or no? 8.1 we have discussed. Okay, so I hope all of you can solve 8.1. Okay, homework, I'm just leaving on you guys for now. We'll discuss homework later. Okay, now let's see some problems of 8.2. Okay, because we have covered the theory, half of the theory of 8.2. Now, when we talk about this, right? Okay, except for the last concept, except for the common ion effect, okay, right? We have discussed these 6 concepts. Okay, so let's solve some basic problem based on that. Right, we have covered this, right? pH of weak acid we have covered, pH of weak base we have covered. Okay, now mixture of 2 acid we haven't covered, right? So we'll just see this.